Hello students, welcome back to e-learning edu. In today's class, we'll be learning about the cathode ray experiment which was conducted by J.J. Thomson, which is also known as the discharge tube experiment. And first of all, let us see the construction of this experiment. See here, there were two electrodes. One is the cathode and the other one is the anode. And the cathode is connected to the negative terminal of the battery and the anode is connected to the positive terminal. And here you can see the vacuum pump through which the vacuum will be liberated out, and the coating of this tube was made by the fluorescent material. So here you can consider this experiment very similar to that of the tube light. So here in the tube light you can see that at the two ends you can see the metallic two ends, right? That is the electrode. One is the cathode and the other one is the anode. And also the fluorescent or the glass type structure by which we can see the glow of the light, that you can consider it as a fluorescent coating or the material, fluorescent material, and then it is connected to the cell or the electricity, right? The experiment is very same. So here he made the hydrogen gas or the hydrogen gas was filled inside this tube. Here you can see the tube, right? Inside this tube at a very low pressure, very low atmospheric pressure, and at very high voltage. This was a condition. The pressure was very low and the voltage was very high, and when the electricity was passed, there was something which traveled from the cathode to the anode. Which can be observed. We cannot observe the flow of light, right? But here, in order to observe this experiment, he made this tube covered with the fluorescent coating. So the flow of light was observed by this fluorescent coating. That is, when the light when electrons, or when it was the light passed from cathode to anode, it was observed with the help of this fluorescent coating. It started to glow. So here from this experiment, he observed that beam of light moved from the cathode to the anode, which was observed through the fluorescent screen. And so beam from, since it is a movement of the light or the beam, it is from the cathode to the anode, it is all known as the cathode ray. And now let us see the observation which is made by him. So here see this experiment figure. So here you can see, right, the two electrodes. You can see one is a cathode and the other one is the anode, and again this cathode as well as the anode both are so here and both are connected to the cell. So cathode to the negative terminal, anode to the positive terminal. So first you need to learn about the construction and then the observation part. And so when the electricity was on, that is in the presence of electricity, or in the presence of electricity, here you can see the passage of light or the beam of light passed, and it was observed through this fluorescent screen. You can see the fluorescent screen. And again the observation was that cathode ray travel from the cathode to anode and are negatively charged. So this was the discovery of the subatomic particles like atom. Okay, so here at that time, so you have to keep in mind that this is a starting, right, initiation. So here no atoms were discovered. From this experiment he observed that there was something which is passing from the cathode to the anode. And also these are cathode to the anode means what, you know, cathode is negatively charged and anode is positively charged. So here negatively charged substance, it moved from the cathode to the anode. And also we cannot observe this ray or the beam of light, we cannot just observe with help of a naked eye. So it is not visible, but light up a fluorescent screen. So here it is not the passage of the light, even though it is not visible. So he has set the screen, right, fluorescent screen. So it is made to visible with the help of the fluorescent screen. So the light, when it strikes upon the, or when it strikes upon this fluorescent screen, it will start to glow. That means there was something which passed from the cathode to the anode, because of which the fluorescent screen started to glow. And next this beam of light, they travel in straight line in absence of electrical and magnetic field. So here you can see, right, so this beam of light, they travel in the straight line, the B point. So here the beam of light, they travel in the straight line in the absence of what, in the absence of electrical and magnetic field. They travel in the straight line. Okay, so here it will be hitting on the point B. And next point is that in presence of electrical and magnetic field, they act as a negative charge. So here in the again this beam of light in the presence of electrical, so here you can see the electrical field and the magnetic field, the north as well as the south pole you can see, right? So here in the presence of electrical and magnetic field, what happens, they behaves as the same as that of the negative charge particle. So the negative also these particles, so at that time atom was not discovered, electron was not discovered, so this electron behaved same as that of the some negatively charged particle. And next point is that the characteristics do not depend on material of electrode or gas in the discharge tube. So I have told you that the discharge tube, it was filled with the hydrogen gas, right? And next he tried to change, or he changed the gas from hydrogen to some different gas. So the observation was same, that is there is something which is passing from the cathode to the anode, because of which the fluorescent screen started to glow up. And again it is moving from the cathode to the anode in the form of a straight line. And so here when he changed the gas, the observation was similar. And again he changed the metals, and you know the electrode and anode, the electrode, that is the cathode and anode is present, right? So here even after changing this electrode, the observation was very same. So he came to conclusion the characteristic do not depend on the material of electrode or gas in the discharge tube. So he observed that from this observation he came to a conclusion that there is something which is passing from the cathode to the anode rays, anode in the form of a straight line, because of the fluorescent screen started to glow. And these electrons were very smaller than that of the atom. So the hydrogen means, you know, hydrogen is the smallest atom, right? So it was said that hydrogen was the smallest atom, but even smaller to the hydrogen there is something present inside. So he made to conclusion that inside the hydrogen the electron is present, and he gave the plum pudding model of this atom, or the watermelon model. So here as this is known as the Thomson model of atom. As per this you can see the electron which is embedded inside the atom. And when we consider the watermelon, you can see the red part, right? So the red part which is spread evenly throughout, we can consider it as a positive sphere, and inside that the seeds of this watermelon, you can consider it as this electron. Okay, so here electrons are embedded inside the positive sphere of the atom.